Hello friends, welcome back to our channel. So in today's session we'll see one more concept in operating systems, that is deadlock avoidance. So in our previous session we have seen the methods which handles the deadlock situation. In that, the first one is a deadlock prevention, deadlock avoidance, deadlock detection and recovery, and finally the deadlock ignorance. So today's session we'll see one concept of deadlock avoidance. One algorithm which can avoid the deadlock situation is a banker's algorithm. So without delay, let's start today's session. Banker's algorithm, which is a deadlock avoidance technique. So before the deadlock occurs, while allocating the resources itself, we need to take care and we have to allocate the resources such that the result does not lead to the deadlock situation. So here the main concept of Banker's algorithm is allocating the resources to the processes without having the deadlock. So here we'll be having processes and resources. So process will be represented with P of I. Okay, P of Y, I means the number of resource. So like P0, P1, P2, P3 and so on. So let us represent it with Pi. Okay, and this is Ri, which is nothing but resources, R0, R1, R2. So for example, to understand the resources means, so one resource is a printer. Okay, so printer can be shareable, right? So printers or scanners or any infrastructure, anything, we can call them as a resources. So we need to allocate these resources to the processes, okay, such that it should not yield with the deadlock situation. So for this, there will be a resource count and resource count will be for R0, R1, R2 and so on, right? And similarly, allocated resources. So how many resources have been allocated to the processes, and maximum resources. So this maximum resources means the maximum number of resources that process required to complete its execution. Okay, so this is completely different. Resource count is different, maximum resource is different. Resource count is number of resources that are available. Okay, number of resources that are available, and among that some of the resources will be allocated to the processes. And this maximum resource means if one process wants to complete its execution, how many number of resources it should require. And from this we have to find out, okay, needed resources. So we know the allocated resources, we know the maximum resources that a process required. So the needed resources will be maximum resources minus allocated resources. So we'll be getting the needed resources. So that means some of the resources are already allocated to the process and it requires these many resources to complete its execution. And so among this resource count, some of the resources are already allocated. So there will be one more term called available resources. Available resources. So there will be available resources also. Okay, so after allocating the resources, what are the how many available resources are there? From these available resources, we need to allocate the resources, needed resources, so that the process will be complete its execution. Okay, so a small thing I'll write here so that we'll see an example how we can proceed with this banker's algorithm. So as we said it here, so need resources. The need resources are less than or equal to available resources. See, if need resources are less than available resources, so some resources are already available, and every process will be calculating the need resources to complete its execution. So if the need resource is less than or equal to available, what happens, that resources can be allocated to the process to complete its execution, so that, so we can write process can complete its execution. So before that we can write resources can be allocated. So if the available resources are greater than the need, that means the need resources are less than available. So one thing, resources can be allocated, next process can complete its execution. After that what we have to do, so release allocated resources and update available resources. See, simple. For example, process P0 requires the need resources are 4 and the available resources are 6. Okay, so P0 need 4 resources to complete its execution and available resources are 6. So you can see 4 is less than 6, so we need 4 but we are having 6, so we can complete it. So what happens, these 4 resources will be allocated, the 4 resources will be allocated, and see, P0 completes its execution, right? And what happens, release all the allocated resources, whatever the resources are allocated, that will be released. Okay, see, for example, one more thing I have just to, so already allocated, for example, already allocated are 2, right? So what happens, so 4 has been given to this to complete its execution and we have to update the available. So available will be previously 6 plus 2 are deallocated, right? Already allocated, so it completes its execution, so you can release it. So 6 plus 2, which will be 8. So we have to update the available resources, that's also most important. So only one condition. So if need is less than or equal to available, then we have to allocate the resources, we have to complete its process and release all the allocated resources and update the available resources, right? And the same step will be repeated for all the processes, those who have not completed so far. And finally, check whether all the processes have been completed its execution. If so, we can say that the situation is not doesn't lead to a deadlock. It's a safe state. Okay, so the state is a safe state. So this is also called as a safety algorithm. Safety algorithm. So we are checking whether after allocating the resources, whether the situation becomes safe or not. Right? So hope you understood this one. Simple step, only this one. Just remember. And the same thing should be repeated for all the processes. So now we'll take one example and I'll solve that by using this simple thing. Right? Now let us see this example problem, right? So here we are having a 5 processes. Let us consider this problem, 5 processes, and total number of resources that are available, 3 resources are there, and each resource R naught Available resources are 10, and R1 5 resources and R2 7 resources. So we have to share all these resources to the processes, 5 processes, such that it doesn't lead to the deadlock situation. So here the table was given. Yes. See, P naught, P1, P2, P3, and P4. Let it be some 5 processes. So P naught requires a maximum of 7 R naught resources, 5 R1 resources, and 3 R2 resources to complete its execution. Similarly, P1 requires 3, 2, 2. That means 3 resources with the numbers 3, 2, 2 to complete its execution. So that is a maximum resources required to complete its execution. So till now, allocated resources are P naught, R naught. 0 resources have been allocated, 1 R1 and 0 R2. P1, 3 R naught resources, 0 R1 resources, and 2 R2 resources have allocated, right? So these are the allocated resources, and these are the maximum resources to complete its execution. So these are the need, how many required to complete its execution, and what are the available. So you can see R naught total 10 quantity are available, right? So resource R naught 10 quantity are available. Among the 10, how many have allocated? So 3 plus 3 plus 2. So 6 plus 2, 8 resources have already allocated. So what is the available R naught? Only 2 resources. Hope you understood. So these are the maximum resources available. Okay, available. And we need to share all these resources to all the 5 processes. So some of the resources have already allocated. So coming to the R naught, total number of R naught resources are 10. Among the 10, 3 have been allocated for P1, 3 have been allocated for P2, and 2 have been allocated for P3. So how many resources are remaining? That means available means, so 3 plus 3, 6 plus 2, 8. So 10 minus 8, 2 resources are available. Similarly, R1, total R1 resources are 5 and 2 resources are allocated, one for P0 and one for P3. So available resources are 3. And similarly, R2, total resources are 7 and 2 allocated for P1, 2 allocated for P2, and 1 allocated for P3 and 2 allocated for P4. So total 2 plus 1, 3 plus 2, 5 plus 2, 7. So all the 7 resources have been allocated for different process R2. So available are 0. Available are 0. Now what we have to do? So we required needed. How many resources are required to complete the execution? So coming to the P naught, if P naught wants to get executed, completes its execution, how many resources are required? So R naught maximum 7, 0 are allocated, so need 7 more resources. So R1 5 resources, it requires 5 resources to complete its execution. 1 is allocated, so 4 it need. And R2, no resource have been allocated, maximum 3, 3, so it requires 3. Similarly, if you want to complete a P1, process P1, how many resources? R naught 3, maximum 3, so 0. R1 0, R1 2, so it will be 2. So that means simply we can say maximum minus allocated will be the needed. So 2, 2, it will be 0. So that means if P1 wants to get executed, it requires 0 R0 resources, 2 R1 resources, and 0 R2 resources. Similarly, here also 9 minus 3, 6, 0 minus 0 is 0 requirement, 2 minus 2 it is again 0. And here 2 minus 2 it is 0, 2 minus 1 it's 1, 2 minus 1 it's 1. And here also 4 required R0, 3 required R1, and 1 required R2. So these are the need resources. So we have seen the formula that need resources are less than available. So consider P naught. What are the need resources? P naught need resources are 7, 4, 3. What are the available resources? What are the available resources? 2, 3, 0. See, here the condition, if need is less than or equal to available, then update available. Okay, so 7, need less than availability. So 7 less than 2, false. 4 less than 3, false. 3 less than 0, false. So P naught can't complete its execution with the available resources. Hope you understood. So P naught required 7 R naught resources where we are having only 2. P naught required 4 R1 resources where it requires 3. P naught requires 3 R2 resources where it is required to only 0. So here P1, P naught can't be executed as of now. Now move to the P1. What are the need resources? P1 0 to 0. What are the available resources? You can see 2, 3, 0. See, 0 less than 2, true. 2 less than 3, true. 0 less than 0, true. So remember, all should be true. If any one of the resources is not available, we should not start executing the process. We should not allocate the process. So here it is possible, right? So need resources are very less than available resources. What we have to do, we can allocate the resources to P1 and we can complete its execution so that we can update. So update the availability. So update the availability means availability is equal to availability plus allocated. So updated availability plus allocated means what happens? Availability is equal to 2, 3, 0. What are the allocated resources for this one? 3, 0, 2. Just add these two things. 5, 3, 2. So P1 completes its execution. P1 completes its execution. So after completion of this execution, what happens? So this available resources, so this will be released. 0, 0. This will be released and this will be added to the available resources. So what happens here? It becomes, now available resources are 5, 3, 2 because P1 completes its execution. Okay, hope you understood. Before, while executing the P1, need resources are less than available. So whatever the available resources, that will be allocated to P1 and it will be get completed. So once it was completed, we need to deallocate the resources which are already allocated. So 3, 2. So that becomes zeros. So that will be added to the available. So that will be added to the available. Now coming to this P2. What is the P2? Need resources. What are the P2 need resources in order to execute it? So 600. So it requires 6 processes. Okay. So 6 resources. Availability, what is that? 532. Now you can see 6, it is false. This is true, this is true. So if any one of these false, this cannot be continued. So P2 can't be continued right now. Move to the next one, P3. Need resources. What are the need resources for P3? 0, 1, 1. What are the available resources for P3? 5, 3, 2. So this is true, this is true, this is true because need resources are less than available resources. Okay. Now what we have to do? Available, we have to allocate it. Allocate this one to the P3 and let it be completed. So available will be 532 plus allocated resources 211. So which becomes 7, 4, 3. So now it becomes 7, 4, 3 and this becomes 0, 0, 0. Because P3 has been completed its execution. Now just move with the P4. What is the need? The need resources for P4 is 431 and avail resources are 743. So true, true, true. So 4 is less than 7, 3 is less than 4, 1 is less than 3. Now what happens here? Avail should be updated. So avail is equal to what are the available resources? 743 plus allocated resources 002. So that becomes 745. So this becomes 745 after completion of this P4 and this becomes 0. So resources will be deallocated. Now again start the same thing, repeat the same thing from starting onwards. Okay, so coming to the P0, because P0 not completed, right? So it need how many? What are the need resources? 743. These are the need resources for P0. What are the avail resources? Available resources are 745. So what happens? This is true, and this is true. Now we need to update the avail resources. Avail resources will be 745 plus whatever the resources allocated 701. Sorry, 010. Okay, 010. This becomes 755. 755, right? So this becomes 755 and this is completed and this becomes 0. Okay, yes. Now what we have to do? One more process is available. So that is P2. Need R, P2 need R 600. Available R 755. So automatically true, true, true. So then we have to add available resources with 755 and allocated resources for P2 it is 302. So which becomes 10, 5 and 7. So this becomes 10, 5, 7. So now we completed P2, this becomes 0 and this becomes 0. Now you can observe all the processes have been completed its execution. After completion of this execution, what are the available resources? You can see R0 7, R1 5, R2 7, which are the available resources here, right? So if we get the same thing, we can simply say that it is in a safe state. The situation is in a safe state, so deadlock will not be occurred. So here the completion order of completion will be first what is completed? P1 completed, then P3 completed, then P4 completed, P3 P4 completed, then P0 completed, then P2 completed. So this is the order of completion of the processes. That means allocating the resources to the processes such that there will be no deadlock. So this is called a banker's algorithm, which can also be called as safety algorithm. Right? So hope you understood. Simple thing. So some resources are already allocated to the processes and maximum resources will be given. So these are the maximum resources the process required to complete its execution. From that we have to calculate the need resources. How many resources are still needed to complete the process, and we have to find out the available resources, and only one condition we have to check, that is if need resources are less than available, simply allocate the resources to that particular process and let the process complete its execution, and then release all the allocated processes that are already all the resources that are already allocated to the processes, and update the available resources, and repeat the same step for all the processes until all the process completes its execution. So here we need to get all zeros, allocated resources all zeros means all processes have been completed its execution, and every process have released the resources, deallocated the resources. So finally, after completion of the thing, the available resources will be the maximum resources available. So 10, 5, 7 and 10, 5, 7. So every process we are checking the condition need less than available, and we are proceeding with the further. Right? So hope you understood this one, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I'll try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.